Okay, let's unpack this deep dive. We've got a fascinating stack of source material here.
Yeah, it's essentially a lookbook at interventions for alcohol use disorder, AUD.
Right, and not just the established medications. This stuff goes way back.
Exactly, from, traditional botanicals used for centuries.
Ancient wisdom, kind of.
All the way to really cutting-edge research, looking at new targets in the brain.
So our mission here is to sort of cut through that complexity.
Yep, pull out the key insights, the important bits from these sources for you.
Give you a shortcut, basically, to understanding the challenges of AUD and, well, the different ways people are trying to tackle it.
Because it affects millions, and while we have treatments, there's a real need for maybe more effective, more targeted options.
And what's striking right away is just how broad the net is cast in these sources. They're looking everywhere.
Absolutely. AUD is incredibly complex, isn't it? Brain chemistry, genetics, psychology.
A lot.
And the sources really reflect that. They explore a huge range of approaches.
Maybe we should start with those traditional routes, the botanicals. What stands out there?
Well, what's remarkable is how some ancient practices might have, hit upon things that target pathways we're only now fully getting.
Like kudzu.
Yeah.
That comes up a lot.
Yeah.
Traditional Chinese medicine, right?
Exactly. And the sources mention studies showing it can actually help reduce alcohol intake.
How so? Like specifically?
Specifically things like how often someone sips or the total amount they drink. It's subtle.
Interesting. Not just making you feel awful if you drink, but actually changing the behavior. How?
Yeah, and that's where the nuance comes in. A key compound, Daidzein.
Daidzein, okay.
It seems to work differently than, say, disulfiram. It doesn't cause that widespread toxic reaction.
Right.
It looks like it specifically inhibits an enzyme, ALDH2.
ALDH2, got it.
But in a way that seems to uniquely affect how brain chemicals break down. Serotonin, dopamine.
Oh, okay.
So the idea is that a buildup of specific brain aldehydes, not the systemic ones, reduces the drinking behavior.
Like a gentle nudge to brain chemistry, you said earlier. Not a sledgehammer.
Precisely. A very different approach.
What about other plants? The Japanese raisin tree, Hovenia dulcis.
Hovenia is another compelling one. Its active compound is Dihydromyricetin, or DHM.
DHM, okay.
And the preclinical work in the sources highlights its dual action.
Dual action. How?
Well, first, it seems to help the liver process alcohol faster. Sort of protective, maybe.
Okay, that makes sense. Detox support.
But maybe more importantly, it interacts directly with GABA receptors in the brain.
GABA, the brain's main calm-down signal.
Exactly. Alcohol messes with that system, right?
Yeah.
Causes intoxication, then withdrawal is the rebound.
Right.
DHM seems to counteract some of alcohol's effects there, potentially easing intoxication and withdrawal.
So it's working on both sides, helping the liver and calming the brain.
That's the idea, yeah. Working on detox and brain signaling.
So we're seeing different strategies, metabolism, brain signaling. The sources mention others too, don't they? Thyme, salvia, though maybe less human data.
Yeah, thyme showed some anti-anxiety effects in mice during withdrawal. Salvia miltyrhiza might reduce alcohol absorption. But, and this is crucial...
We have to be really careful. Natural isn't safe automatically, especially with AUD.
Absolutely critical point. The sources hammer this home. Safety validation is paramount.
Because some traditional remedies have risks.
Big risks. Syrian rue Paganum harmala contains MAOA inhibitors. Very dangerous with certain foods or meds. High blood pressure crisis.
Wow, okay.
Even St. John's wort, often used for mood, interacts badly with alcohol and also has MAOI properties.
So rigorous research needed, no question.
Non-negotiable. Safety first.
Okay, shifting gears a bit. Away from plants. The report also gets into modern science, novel biochemical targets. What's emerging there?
This is pushing the boundaries, Beyond the classic neurotransmitters, the sources highlight neuroinflammation.
Inflammation in the brain, linked to AUD.
Yeah, chronic alcohol seems to trigger it, and that inflammation contributes to the dependence cycle.
So targeting that inflammation could be a new treatment angle.
Exactly. Compounds like PDE4 inhibitors are showing promise. Things like apremilast.
Apremilast? Isn't that already used for other things, like psoriasis?
It is. Approved for inflammatory conditions. So it's an example of repurposing a drug with a known safety profile.
And the early studies look good for AUD.
The material points to animal models and early studies where it helped reduce alcohol intake. It's definitely compelling.
Okay, so wrapping this up, what does this all mean for you listening?
Well, we've seen AUD is complex, right? Requires diverse approaches.
Yeah, approaches targeting metabolism like DHM might,
Or rebalancing brain chemistry subtly, like Daidzein seems to with those aldehydes.
or hitting receptors directly like DHM and GABA.
Or even tackling underlying issues like neuroinflammation with candidates like apremilast.
We've looked at leads from traditional medicine Kudzu, DHM, and seen how repurposed drugs like apremilast offer new paths.
And we shouldn't forget the established options, naltrexone, acaprosate, they're still foundational.
But what's really fascinating is digging into how these things might work. Daidzein's enzyme thing, DHM's dual action.
Right, the mechanisms.
And given how AUD varies so much from person to person, it raises a big question, doesn't it?
Definitely. If you connect all these threads...
Could the future be like a highly personalized toolkit?
Exactly. Imagine combining insights from ancient wisdom and modern neuroscience.
Interventions tailored precisely to your biology, your specific needs.
It's something to think about, isn't it, as this whole field keeps evolving.